This session will be recorded and will be uploaded later in my Facebook page, also in my YouTube page. So anyone who missed it can watch it later. All right, so let's begin. And please ignore the background. This is my basement. And this is the one that USMLE Step 1 tutoring. Before going to discuss, before going to the main topic, let's tell you something about my business that tomorrow I'll be starting a new session of USMLE Step 1 tutoring, two new sessions actually, one in the morning, one in the evening. And every time, the times are in New York time or Eastern time zone, and the morning session will start at 5 a.m. in the morning, and the evening session starts at 6 p.m. And here's the schedule. You can see that 16 weeks of session, and this 16 weeks of session will include every topic you're gonna see in your USMLE Step 1. And this after this 16 weeks, I hope you will be prepared. So anyone interested to join in, let me know after the class. I will tell you how to contact me. And also here's about the fees, a little bit about a little glimpse about the fees. The fees are really very minimal, $60 per week. So for 16 weeks, if you join the full course, it will be about $960, something like that. But if you want to join the full course and you say, okay, I'm committed to do the full thing, there will be a discount. You will pay only $800. All right, so let's jump into the topic. So today I'm gonna discuss some critical topic of very critical topic actually, which gave me very hard time during my own preparation. That is acid-base imbalance. But before going to that topic, that acid-base imbalance discussion, let's talk about USMLE first. So as you all know that it's a journey and it's a big journey, that it starts with some exams but ends up with some procedures. You need to take the exams, you need to pass the exams with good scores, and there's other credentials that you need to manage, like there is different things. If you are like me, an international medical graduate, there will be something called year of graduation. There will be something called United States clinical experience. There will be something called LOR, the letters of recommendations. These things can bog you down. So when you start this journey, you need to think about the whole procedure. It's not only exams, but it's a procedure, it's a journey. You need to run all the way up to the match, and you need to go through all of this. But eventually, we usually go through all of this. So I hope everyone can go through these things. And I passed the steps, and I'm applying this year for the residency application. Let's see how my journey ends. All right, so now for the USMLE Step 1, as you were, I hope you were joining the session for USMLE Step 1. So in this case, one thing that bothers all of us, that is the resources, that which resources should I use? So if you ask me that which resources should you use, I'll say, okay, as a pure professional businessman, I would say, okay, join my tutoring session. You won't need anything else. But to be more realistic, that you need to use other resources, and if you can use them, you don't need a tutor. The resources, keep them simple. One rule, keep them simple. Just if you ask me that which resources you should use for USMLE Step 1, I would say, okay, so just use let me see if I wrote it here. No, I didn't. So let me write here that which resources you should use. And I think the very common and very used resource, that is first aid. If it stands for first aid, make sure to use the latest version of it. Then use the question bank. There's a lot of question banks out there in the market, but I think everyone uses the UWorld. And if you want to use some other uh, video resources, like if you ask me, okay, the pathology, it's huge, and does the first aid and UWorld can cover the whole pathology? I need to watch something else. You go for pathology. So if you use these three resources and you stick with these three resources, you're fine. You're all set. And I know people who just stick with these three resources and did great, like 250s, 260s. And it depends on you that how well you can retain these things. All right. Again, if you need a push or a proper guidance or a tutor, I'm here. All right. So now, one other thing that some people, some students ask me that how many weeks, months, or years should I study? It really depends on you. You know better yourself. Uh, Suppose I took about 8 months for step one, but I know my friends who took really less time, like 6 months, or some. If you think in the way of the USMDs, they take like 2 or 3 weeks. But although they read like this, the way the USMLE questions are asked, they read like this for 1 or 2 years. Then they take 2 or 3 weeks to prepare for USMLE step one. So if you're an IMG and you are starting, suppose you haven't touched your book for many years, it can happen. I know many seniors of mine, and one of the senior I can tell, and he was about, when he applied, he was 12 years old graduate, but he matched on the first time because his scores were good. And what he did, he studied after so many years, but you can say that, okay, he is talented or he is so much genius or something, but I don't believe this thing, because I think you need to work hard. The more you work hard, the more better chance that you do good results in these exams. So hard work beats talent in case of everything, in case of USMLE. All right, so now let's discuss the most pathetic, or you can say most bothersome uh, thing or topic in USMLE. Maybe not for you, but for me, it was really pathetic. So this is acid-base imbalance. Acid-base imbalance, and you might see 2 or 3 or maybe 4 questions in your main exam when you are in the Prometric Center and sitting for the USMLE Step 1, and you might see this questions from this topic. So be prepared for this thing. So I wrote here the most favorite topic of every medical student, or should I say most feared. Uh, Whatever it is, let's see how well we can go over it. So let me first say the normal ranges. So the normal ranges, you need to know some normal ranges for this topic. By the way, before going to the topic, let me discuss how the questions can be asked in your USMLE Step 1 exam or Step 2 CK exam, how the questions can be asked. One way they can ask the question that they give you this lab values, this acid base values or ABG interpretations. Like they will give you the pH, they will give you the partial pressure of carbon dioxide, they will give you the level of bicarbonate in the body, and they will ask you what is the problem. In that case, this is much simpler, that if you know that how to interpret these things, this pH, PCO2, and bicarbonate, you can go and reach your decision. Okay, this might be the problem. Another way they can ask you the question is they give you the problem and they give in the options, like options A, the pH is this, PCO2 is this, and bicarbonate is this. Option B, some other parameters. Option C, option D. They give you the problem, and you need to find what is the lab value pertinent to that problem. So this is a much more difficult thing, but again, if you know the cause is good, it will be easier for you to answer. Usually, in your first aid, if you know your first aid, if you read your first aid, there's a list of cause, a picture, a graph that shows you the causes of these different acid-base modalities. And when you do the UWorld questions, you're all set. All right. So, what is the normal range of different lab values pertinent to the acid-base imbalance? The first, the blood pH. I hope all of you know what is the blood pH is. pH is the presence of H. That means how much hydrogen ions are in your body. So the hydrogen ions, they are, we know just simply, they are acids, right? The protons are hydrogen ions, these are acids. The more H plus in your body, the more acidic you are. And this pH scale is somehow inversely related to the hydrogen ion. So the more the pH, more the hydrogen ion in your body, the less the pH. The less the hydrogen ion in your body, the more the pH. So you can interpret it like this, that when the pH goes high, there is more alkalosis because hydrogen goes down. When the pH goes down, that is more acidosis because the hydrogen ion goes high. So H plus goes high, pH goes down. H plus goes down, pH goes high. All right. Now, this thing, the normal blood pH, there's a range of normal blood pH, and that is 7.35 to 7.45. Okay. And there's some other ranges, like as I told you earlier, that when you discuss this acid-base imbalance questions, they give you some other lab values, like partial pressure of carbon dioxide. What is the normal level of partial pressure of carbon dioxide? So this thing, PCO2, it can range from 38 to 45 millimeter of mercury. So this is the normal range, 38 to 45 millimeter of mercury. And what about the bicarbonate level? The bicarbonate level, and this can range from 20 to 28, and the unit is milli equivalent per liter. But again, we usually see, okay, so in your questions and for this USMLE step 1 purpose, usually you'll see that this is 24 milli equivalent per liter, a single number, that's cool. So why you need to remember this thing? The pH, you know it, that's 7.35 to 7.45. If it is less than 7.35, all right, voila, this is acidosis. More than 7.45, alkalosis. That's it. PCO2 or carbon dioxide. Why you need to know this? Bicarbonate. Why you need to know this? So in a simple sense, if this PCO2 goes high, it is acid. PCO2 is acid, and if PCO2 goes more than 45, there is acidosis. And if PCO2 goes down below the 38, this is alkalosis. And simply, very simply, if you think, okay, the carbon dioxide is controlled by our respiratory system. Although there is carbon dioxide production in all of our cells of the body, but ultimately the respiratory system are controlling this thing. So when there is change in carbon dioxide, whether it is acidosis or alkalosis, we give it a tag. We call it respiratory. So if the PCO2 goes high, more than 45, we call it respiratory acidosis. PCO2 goes down, less than 38, we call it respiratory alkalosis. For the bicarbonate, this is an metabolic thing. It sounds like a chemical, and we know that in metabolic aspect of our life, there's some chemical reactions. So when the bicarbonate, in this case, it's inversely related. When the bicarbonate level goes below this level, below 20, we call it acidosis. And when it goes high, we call it alkalosis. So these are inversely related. But you can ask me why. Why is this thing? All right. So before going there, let me give you some very basics like acidemia, alkalemia. Acidemia, alkalemia, what does it mean? Acid in blood, alkali in blood. But does that mean they are acidosis or alkalosis? I don't think so. But what I think that when there is acid in the blood or alkali in the blood, there is acid in the blood, there is alkali in the blood. They're in normal range. But when they cause diseases, we call them acidosis or alkalosis. So significant amount of acid, significant amount of alkali in the blood, we call it acidosis or alkalosis. All right, but you now understand that, okay, there may be acidosis, alkalosis. There may be metabolic acidosis, there may be metabolic alkalosis, respiratory acidosis, respiratory alkalosis. But to make your life easier, the USMLE will ask questions about the mixed problems. That these are not just simply one problem, there might be mixed problem. And this mixed problem will make your life, what I said, easier, forget me, make your life harder. They will ask this mixed problem questions. But the more you practice, you'll be fine. You'll be fine. No problem, no worries about it. All right, so now let's see. Okay, so this thing, this Henderson-Hasselbalch equation will help you understand why the carbonate or why the carbon dioxide um, controls the change in your body pH or controls your acid-base status. So what is the equation? It's these two guys, Henderson and Hasselbalch. Um, we are very grateful to them because they invented this equation, and sometimes we'd like to curse them, right? To make our life so hard. All right, so the guys, they invented this equation that pH equals 6.1 log scale. I don't know what is this log scale. Oh, sorry, 6.1 plus log uh, level of bicarbonate divided by 0.03 level of PCO2. Very easy, right? I don't have an idea what is this equation is about because I'm a med student, not a math student, and I was a math student, but as I hate math, I left math and came to med school. Trust me, I really did that thing. All right, so here you see that this bicarbonate is on top. That is, it's the numerator, because we know if we write something like this, the top one is the numerator and the bottom one is the denominator, right? So just forget this thing, the 6.1 log or anything. The pH equals the bicarbonate divided by PCO2. Just forget this thing also, 0.03 PCO2, whatever. Now, if this bicarbonate goes high, what do you think? The numerator goes high, this answer, the equation will go high, the answer of the equation. That means the pH will go high. The bicarbonate goes down, pH goes down. Simple. The PCO2 goes high, pH goes high. PCO2 goes down, pH goes down. That's it. So if you follow this equation, these guys actually did a really great thing, that they simplified the whole uh, you can say this problem or confusion of acid-base imbalance in this simple equation, although not so simple. They created this equation, and you see that when these levels, this bicarbonate level goes high, the pH goes high. That means if you see in your lab that bicarbonate level is going high, at the same time pH is going high, you can say, okay, there may be problem with the metabolic alkalosis. The bicarbonate level goes down, pH goes down, okay, there is problem with metabolic acidosis. Same time, the PCO2, that means the partial pressure of carbon dioxide goes high, the pH goes high. No, the partial pressure of carbon dioxide goes high as it is the denominator. This result should go down. Did I say it wrong earlier? I think I should. I did. If the PCO2 goes high, it's a denominator. If it goes high, the pH goes down, right? Because the denominator is the bottom value. If it goes high, this result will go down. The PCO2 goes down, pH goes high. Now, you can understand that when the PCO2 goes high, pH goes down. That means when the pH goes down, that is acidosis. So simply, what is the take-home for? What is the take-home point? That when the PCO2, in case of PCO2, it goes high, pH goes down, it is acidosis. And as it is PCO2, that means carbon dioxide. And as the carbon dioxide is related to our lung, this is respiratory acidosis. PCO2 goes down, pH goes high, respiratory alkalosis. Vice versa. Bicarbonate goes high, pH goes high. That is metabolic alkalosis. Bicarbonate goes down, pH goes down, metabolic acidosis. Now, what are the disturbances and what is this thing? Compensation. The disturbances are, there is, you already know what the disturbances can be. There can be metabolic disturbances, there can be respiratory disturbances. In the metabolic disturbances, it can be metabolic acidosis or alkalosis. In case of respiratory disturbances, it can be respiratory acidosis or alkalosis. And don't forget, there can be mixed problems, right? But to be amazed or to be very proud of your body, there's something called compensation. When these disturbances happen, suppose we are human and we can have these disturbances anytime, right? We are not perfect. When there is this disturbance happens, the body tries to compensate it. Wow. That means you have a disturbance, a primary disturbance, and the body tries to compensate it. All right. So now how this thing happens, just to give you an idea, suppose there is metabolic acidosis. When there is metabolic acidosis, simply the pH will go down, right? Because it's an acidosis. What happens to the bicarbonate level? As it is a metabolic acidosis, bicarbonate level, remember from the equation, it's the numerator. So when it goes down, the pH goes down. All right. So what will be the compensation in this case? In this case, the body will try to get rid of the carbon dioxide. How beautiful is that? Body tries to get rid of your carbon dioxide. The partial pressure of carbon dioxide goes down as a compensation. And remember from the equation, when the partial pressure of carbon dioxide goes down, pH goes up. So primarily when the pH goes down due to the problem of the bicarbonate, as the bicarbonate is going down, the pH is going down, the body tries to compensate by bringing down your partial pressure of carbon dioxide so that the pH can again go up and towards the normal. So this kind of compensation happens when there is one problem, the other part of the body. Suppose the bicarbonate, it's the metabolic side of these problems. When there is some disorder, the respiratory side try to compensate it. When there is respiratory problems, the metabolic side tries to compensate it. And simply, we say that, okay, in the respiratory side, the lung try to compensate it, and in the metabolic side, the kidney, by retaining or releasing bicarbonate, try to compensate these problems. But one thing you should remember that these compensations are not full compensation. It's kind of, suppose there is a uh, road traffic accident, or there is some fire in some house which is owned by some government or something like that, and there is some fatality, some people are dead. And what the government does, okay, all right, give them some compensation, give them some money. You cannot compensate a life, right? You cannot compensate a life with money, no matter how much, how big that money is. It's kind of like this. When the body tries to compensate it, it cannot fully compensate it. That means the pH, suppose let's take an example, the pH may be 7.3 and this is less than 7.35. So this is obviously acidosis. Now when, suppose this is due to metabolic acidosis, the bicarbonate level is suppose 15. And now the PCO2 will try to go down and bring this pH back towards normal. But it cannot bring it in this range. Never, usually. It cannot bring this thing usually towards normal. 7.45, 7.35. It cannot bring it back directly. So when there is compensation, and it's a take home point for the USMLE step 1 exam also, suppose they gave you this uh, levels of ABG and they asked you to interpret it. And when they ask you to interpret it, if you find that the level, the pH level is normal, the pH level, the range is normal, but this bicarbonate or the PCO2 levels are not in normal, what you can think? You can think, okay, maybe there was a problem and there was some compensation so that the pH went back to normal. Don't make that mistake. If you see that the pH level is in normal range, 7.35 to 7.45, but at the same time, the PCO2 and the bicarbonate levels are not in the normal range, you will think some mixed disorders. Usually in the mixed disorders, this thing happens. This change or this uh, normal range of pH we can see. It can happen, suppose I can give you an example, if it happens that there's a body problem where there is metabolic acidosis, at the same time, there is respiratory alkalosis, the both sided problem, one in the acidotic side, one in the alkalotic side, and the body pH can be normal, but the body is having some mixed problem. So what is the takeaway home point? The point is when you see a normal pH, range is normal, but the perimeters, the ABG, that is the PCO2 or bicarbonate levels are not normal, think of some mixed disorders. But usually they ask you questions where you see that there may be some compensation going on, but when there is compensation, you won't find a normal pH. The pH level won't be normal. It can be towards normal, but it won't be fully normal. All right. Now, what is next? Next is some respiratory acidosis. So uh, there's different causes of respiratory acidosis in your book, The First Aid. Let me show you my book. My one is older. It's too heavy. This is First Aid USMLE Step 1. Buy this thing and try to buy the latest version and try to annotate it like this, like I did. Look, so much annotation, so much annotation, so much annotations. Do it like this. Make it heavier so that you can exercise with it. All right, so this thing, this respiratory acidosis, what happens here? There is increase in carbon dioxide, right? There is increase in carbon dioxide in the body. Let me discuss some causes of respiratory acidosis. Suppose, have you heard of this thing, heroin intoxication? What happens? Heroin is a drug, right? So the people who take the heroin, and you can uh, remember an anatomic site through which they sniff the heroin. This thing, let me show this thing. This is the anatomical snuff box. They put the heroin here and they sniff it. I don't do it. Don't get me wrong. So this thing, this heroin intoxication, this heroin, when it goes in the body, what it causes? It causes depression in the respiratory center. So this person cannot breathe out that frequently. So when you cannot breathe out that frequently, there will be accumulation of carbon dioxide in your body. right? And when the carbon dioxide goes high, the pH goes down. Remember that equation? All right, so there's some another cause like some lung diseases, acute lung disease or chronic lung disease like COPD. You can have this thing. Opioids or sedatives, this can cause this respiratory acidosis. And if there is some weakening of the respiratory muscle due to any cause, we can say, okay, late stage of Guillain-Barré, weakening of the respiratory muscles. So these are some causes of respiratory acidosis. I'm not going over all of them separately, but you have the idea that when there is this thing, respiratory acidosis, there is a retention of carbon dioxide in your body. All right, so again, just to remind you that there is some compensation method for this disease. So what is the compensation for respiratory acidosis? And why you need to know this thing? All right, so just before going to why you need to know this thing, let me tell you what is this compensation is. So you know that when there is respiratory acidosis, there is increase in PCO2. And you also know that the compensation will be from the metabolic side. That means there will be some change in bicarbonate so that it can bring the pH towards normal. So what is the normal sense is telling you? When there is increase in PCO2, the bicarbonate will also try to go high so that it can bring the already lowered pH towards normal. That means it try to increase the pH a little bit high. Now, what is the rule? It follows a rule. It doesn't really do it randomly. Okay, the body thinks there is respiratory acidosis. Okay, there's respiratory acidosis. Just bring the bicarbonate high. No, not like that. There's a rule of compensation. When this PCO2 goes 10 millimeter high, suppose the PCO2 is going 10 millimeter more, the bicarbonate will rise for each 10 millimeter. For each 10 millimeter, it will rise 1 milli equivalent per liter. That means if the normal PCO2 is suppose 40, if it becomes 50, the bicarbonate, if it is the normal range is 25, it will become 26. That means for each 10 millimeter rise in PCO2, the bicarbonate will goes high for 1 milliequivalent per liter. That is the rule of compensation. Now you know, okay, doc, I know what is the rule of compensation, but why I need to know this thing? All right, here's the thing. Remember what I told you? There can be one single disease, there can be mixed disease. So when they give you this APG, what do you need to do? You need to first identify what is the problem. Suppose you identified, okay, there is some respiratory acidosis is going on because the pH is less, the PCO2 is high, right? The PCO2 from 40, it becomes 50. You are sure, okay, there is respiratory acidosis is going on. Now, what do you need to do? You need to check the bicarbonate level they gave you. If you see that the bicarbonate level is not matching with the rule of compensation, it will rise for sure, right? Because the bicarbonate will try to rise and try to compensate that pH. But if you see that it is not following that rule of compensation you learned here, what do you think? This is not a compensation. This is a mixed disease. And that's why you need to know this thing. So again, to repeat, you are given an ABG and you are thinking, okay, this is respiratory acidosis and I am the champion of the world because I know this thing. Then you saw that, okay, this is respiratory acidosis. So let's check what is the bicarbonate level. And when you see the bicarbonate level, you need to calculate it with your known formula of compensation. If it falls into the formula, okay, that's good. The body is trying to compensate it. But if it does not fall in the compensation formula, then you need to think this is a mixed disorder. But usually they don't complicate your life with the respiratory acidosis and the compensation thing. Usually they do it for step one. They do it in case of metabolic acidosis, and we're gonna go there very soon. All right, so this is the rule of compensation for respiratory acidosis. Anion gap. So this anion gap, this is very important to understand because I myself had very crucial time understanding it. Oh my God, what is this thing, anion gap? Why there is an anion gap? Where there should be an anion gap to make my life so much critical and so much pathetic. All right, so but there is an anion gap. You need to learn it. So what is an anion gap? Thing is, our body is neutral. We may not be neutral, but our body is neutral. If I ask you, whom do you support, Democrats or Republic? You'll say, I am neutral. I don't support anyone, but I like the way the Trump speak. So what is it? Are you neutral? No, you're not. No one is neutral. You have inside your mind someone. You like someone. But our body is neutral. There is neutrality in case of charge. In case of charge, our body is neutral. There is same amount of positive charge and same amount of negative charge in our body. That means the positive ions, you count them, the negative ions, you count them, you calculate each of them. Okay, they're same amount, the body is neutral. So why there is this gap? All right, the thing is, which are the ions that comprises this positive and negative ions? So if I ask you, okay, name some positive ions that are in our body, all right, you say, okay, that's nothing. There is sodium, there is potassium, there is calcium, there is magnesium, so much positive charges. And if I ask you, okay, what are the negative ions you think there are in our body? You say, okay, this is nothing. There is chloride, there is bicarbonate, there is phosphate, there is a lot of plasma proteins in our body. Those are negatives, right? So now, when you try to measure them in real life, when you try to measure them, what you can measure? You can measure all of the positive ions, mostly all of the positive ions, but more precisely, you can measure the sodium and potassium. You can measure them in your body. When you try to measure the negative ions, you can measure almost all of them. But when you try to measure the plasma proteins, that's a big headache. You cannot measure them all. So when you measure the positive charges, like these are the positive charges in your body, a bar, and when you measure the negative charges, you see that you cannot measure all the negative ions in your body. You can measure some of them, but not all of them. So there is this gap. There is this gap that you cannot measure. You know that the body is neutral, right? So the measurement should be same on both sides, on the positive side, on the negative side. But when you try to measure it, you see that you can measure the positive ions, but you cannot measure all the negative ions. So what happens? There is this gap here, and this gap is the anion gap. As you cannot measure all the anions or the negative ions, there's a gap in your measurement of measuring the anion or the negative ions. That means this is a gap, and this gap is called anion gap. Now, you know what is anion gap and what is the normal level. It is a normal finding. What is the normal level of anion gap? And this is 8 to 16 milliequivalent per liter. This is the normal anion gap, 8 to 16 milliequivalent per liter. Now, here comes the beauty of life. There can be metabolic acidosis, where there can be a normal anion gap, there can be an increased anion gap. So why this thing happens? Sometimes you find there is normal anion gap metabolic acidosis. Sometimes you find there is increased anion gap metabolic acidosis. Before going there, let's discuss some increased anion gap metabolic acidosis. What are the causes of increased anion gap metabolic acidosis? Well, if someone ingests some acid like methanol, it's an acid. If someone ingests it, there can be increased anion gap metabolic acidosis. Let's take some simple example like DKA, diabetic ketoacidosis. There is some keto acid in your body, in our body, and that causes metabolic acidosis, and that is an increased anion gap metabolic acidosis. There can be some other cause, like if someone has ingestion of what happened? If someone has ingestion of iron tablets, we discussed number 1, 2, 3, ingestion of iron tablets or INH, isoniazide, those can produce acid in our body and cause increased anion gap metabolic acidosis. But why? You know that when you know the basic things, you can interpret the cause. So why there is increased anion gap metabolic acidosis? What happens here? We know that the the anion gaps are measured from the difference between the positive ions and the negative ions. So if you take into account the positive ions, the prominent positive ion here is the sodium. The potassium is so much less, you can ignore it. And if you try to measure the difference with the chloride and the bicarbonate, as we know that there is an anion gap because we cannot measure all the anions, this this equation gives us a approximate idea of anion gap. This represents our all positive ion, this represents our all negative ions. And these things, as we cannot measure all the negative ions, this will give us this gap of 8 to 16 milliequivalent per liter. And this is our approximation of the anion gap. Now, what happens if someone ingests some acid? Suppose I am an alcoholic person. I want some alcohol, but there's no alcohol out there. So what I did, I went to some engine store or car store and I found some methanol and I ingested those because it's supplementary to alcohol. And what will happen in our body, in my body, there will be acid in my body. And if you write the acid in case of chemical formula, it's something like this: A plus H, sorry, A minus H plus. H plus is the acidic part, and A minus is the counterpart of that acid part. When you break some acid, suppose if you break the sulfuric acid, H2SO4, you can write it like this: H plus plus HSO4 minus. So in the acid, in each acid, there's a proton and there's this negative counterpart or anion. So suppose I ingested this acid. Let's take a fresh page. I ingested this acid, all right? What happened that this thing is in my body now, and this is the anion part, and this is the H plus or the cation part or the positive part. What it does, this H plus, it binds with the bicarbonate. It loves bicarbonate, and bicarbonate level will go down in my body. And remember from our Henderson-Hasselbalch equation, when the bicarbonate level goes down, there is acidosis. And that's why when you ingest some new acid or there is production of some new acid, suppose in DKA, diabetic ketoacidosis, there is production of new acid, your body pH goes down. Why? Because your bicarbonate goes down. Why? Because this new acid binds with the bicarbonate and brings it down. So this bicarbonate level goes down and your body pH goes down. You are acidotic, right? Now, what happens if you draw that chart or that diagram again, that this is your positive ions and this is your negative ions, the ions that we can measure, right? And this is the gap. This is the anion gap. We cannot measure it. And now divide it. Suppose this is your bicarbonate. This part is your bicarbonate. And this part is your, let me take another color. This part is your chloride, right? Now, when there is ingestion of new acid, what will happen? That this part, this bicarbonate part, will go down. This bicarbonate part will go down, right? And what will happen? You can see that this gap is increased. This anion gap is increased from before. And that's why when there is some new acid in our body, either it is from outside or it is from inside our body, there's more acid production, there is increased anion gap. There is increased anion gap. But you can ask me, okay, so this is increased anion gap. What is normal anion gap? And why there is normal anion gap and why there is increased anion gap? Let's see. Let's go to the next page, and there is some causes of normal anion gap metabolic acidosis. By the way, I'm not going over the causes each and every one, but when you read those things in your first aid, try to think, okay, this can be like this can be like that. This thinking is very important because in your USMLE exam, in your uh, main exam, you won't find any question that is just popping out of your mind. You need to think anything, any question, you know it already, but you need to think. So this thinking is very important. So whenever you read anything, try to think, okay, this can be this can be that, this can be like this thing. Not doing this thing, but try to think. Now, what are some causes of normal anion gap metabolic acidosis? A very simple example, diarrhea. Diarrhea is the cause of normal anion gap metabolic acidosis. What happens here? There's loss of bicarbonate. Simple. There's loss of bicarbonate and there is normal anion gap metabolic acidosis. So let's draw that thing again, that graph or chart or picture that you can understand that, okay, suppose this is the positive charges in your body and this is the negative charges in your body and this is the gap. Sorry. This is the gap, that is the anion gap. This is normal anion gap. Now, this part, this top part comprises our bicarbonate. This bottom part comprises our chloride. Now, in diarrhea, you are losing the bicarbonate. So what will happen? This bicarbonate level goes down, right? This bicarbonate level goes down. But what do you think? When the bicarbonate level goes down, previously we also saw that bicarbonate levels went down and the anion gap increased. Do you think the anion gap will increase here? No, the anion gap remains the same. Why? The chloride level goes up. The chloride level goes up and it compensates this loss of bicarbonate. And there is no gap. There is no increase in anion gap. So you might ask me, okay, previously you said that when there was a methanol ingestion, there was decrease in bicarbonate, and at the same time, there was increase in anion gap. What happened to chloride then? Why didn't chloride increase in that case? Okay, let's draw this thing here so you can understand why this thing happened. That this is the positive ions and this is the negative ions, okay? And this is the gap, right? In case of methanol poisoning, that means the person is ingesting some new acid. Here is the bicarbonate level and here is the chloride level, right? So when this person is ingesting the new acid, I say that, okay, the new H plus is bringing this bicarbonate level down and this gap is increasing. In this case, the chloride level is not going high, but in this normal anion gap, the chloride level is going high and compensating the loss of bicarbonate. So you might ask me, okay, so what happened in case of increased anion gap metabolic acidosis, that the bicarbonate level went down, but the chloride level didn't go high? Why? The thing is, remember, the new acid, when it came, it was something like this: A minus and H plus. The H plus was bringing the bicarbonate level down, but this A minus, that's an anion, and that is sitting here. This A minus, if you take it in another color, suppose this is the A minus, this A minus is sitting here, right? But in that case, chloride is not going high because there is already an anion. It does not need to go high to compensate. There is already an anion. But again, when you measure it, you cannot measure the new A minus. It's a new thing. You cannot measure it. You can only measure the bicarbonate. You can only measure the chloride. And when you calculate the gap, you see in your measurement, the gap is more. But in this case, the normal case, suppose in diarrhea, there is loss of bicarbonate, but the chloride will go high to compensate the loss of the negative charge. This is the body's rule. This is the body's milieu interior. The body tries to keep it in a homeostasis. So when there is loss of bicarbonate due to some cause of diarrhea or something like this, there is increase in chloride to compensate that loss. And when you measure them, this difference, you see that, okay, there's no change. But when there is a new acid ingestion, or there is DKA, or there is lactic acidosis, what happens? The bicarbonate goes down. That's true because new H plus brings it down. But this anion sits here, and the chloride thinks, okay, there is enough anion. I need not to go high. But when you measure them, you cannot measure the new anion. You see that there is an increased gap. So this is the ultimate thing that happens when there is normal anion gap metabolic acidosis, when there is increased anion gap metabolic acidosis. All right, so lots of acidosis. Let's see what is the compensation of this metabolic acidosis. And this is very important because in your step one, they're gonna ask you about this compensation and they're gonna ask you a question about this compensation. Let's get rid of this pink color. I hate pink color. Okay, so what is the rule of compensation for metabolic acidosis? The rule of compensation is, you know, that what happens in metabolic acidosis. In metabolic acidosis, the bicarbonate level goes down. So what will happen as a compensation? The PCO2, which is the partial pressure of carbon dioxide, it will also go down to compensate it or to bring the pH towards normal. Now this PCO2, it will follow a rule. This PCO2 will follow this rule: 1.5 times serum bicarbonate level plus, plus 8 plus minus 2. So when they give you a bicarbonate level and you see, or you are determined, okay, this is a metabolic acidosis, and you are sure, what do you need to see? You need to see the PCO2, or partial pressure of carbon dioxide. If the PCO2 level follows this rule, by the way, this is called Winter's formula. This is called Winter's formula. If the PCO2 level follows this rule, this is a compensation. But if it does not follow this rule, this is not a compensation. This is something else. This is a mixed disorder. You can't remember all the compensation, but at least try to remember this thing, this Winter's formula. That because this is frequently tested, that what is the compensation for metabolic acidosis? All right. Okay, so now there is, let's get into some alkalosis now. Then we ask you some question and finish this thing up. Some causes of respiratory alkalosis, you can understand if there is more carbon dioxide getting out of your body, there is respiratory alkalosis, chance of respiratory alkalosis. One example, pulmonary embolism, very important, pulmonary embolism. What happens here? Remember, there is tachypnea and tachycardia, right? At the same time, chest pain, sudden chest pain. In women or in prolonged sitting, you say, okay, this is pulmonary embolism, more precisely. In that case, the person hyperventilate like this. What happens? The carbon dioxide goes out of the body. And when the carbon dioxide goes out of the body, what happens? PCO2 goes down, pH goes high, respiratory alkalosis. Another example, if you ask me, early salicylate or aspirin overdose, salicylate poisoning in early case. In the early stage of salicylate poisoning, there is stimulation of the respiratory center in the back of your head, right, in the middle. And what happens that there is more respiratory drive and you bring out the carbon dioxide. And when you bring out the carbon dioxide, there is this salicylate causing this early change, and there is loss of carbon dioxide. And when the carbon dioxide goes out of your body, this is alkalosis, respiratory alkalosis. There's some other cause, and what is the rule of compensation? The rule of compensation is, you can remember now that when the carbon dioxide goes down, the pH goes high. To bring the pH down, what will happen? The body will try to release more bicarbonate. The bicarbonate level goes down to bring the pH towards normal. What is the rule? The rule is for every 10 millimeter decrease, every 10 millimeter of mercury decrease in PCO2, the bicarbonate will go down 2 milliequivalent per liter. So it's simple. To give you an example, if the PCO2 level is the normal level is 35 to 48, something like that, right? So if it goes below from 35, goes to 25, this PCO2, the bicarbonate level, which is normally 24, it will go down to 22 milliequivalent per liter. Again, check it out. If it is a compensation or it is a mixed problem. Here's some metabolic alkalosis cause. What is the cause of metabolic alkalosis? Simply, if you ask me one cause, vomiting. Vomiting. When you vomit out, you are bringing out the H plus. The H plus is going out, and at the same time, when the H plus is going out, you are bringing out the chloride. And when the chloride goes out, the body, to maintain the negativity, the bicarbonate level goes high. And when the bicarbonate level goes high, there is metabolic alkalosis. There's some other causes like diuretics use, hyperaldosteronism, antacid use. These are some causes of metabolic alkalosis. What is the rule of compensation of metabolic alkalosis? All right. For every 1 milliequivalent, you know that when there is metabolic alkalosis, there will be increase in bicarbonate, right? And when there is increase in bicarbonate, there will be increase in pH. To bring the pH down, the carbon dioxide level will go high. And what is the rule of compensation? For every 1 milliequivalent rise in bicarbonate, the PCO2, sorry, the PCO2 level will go high by 0.7 millimeter of mercury. You can see that it's much more difficult to retain carbon dioxide. If I ask you retain carbon dioxide, you can do this. You cannot, you just is not breathing out the carbon dioxide, but it is much more difficult. And that's why the body cannot do it very effectively. It cannot retain that much carbon dioxide. And as you can see, the retention is much more slower. All right, so these are the total problems. And here's the question for you, that here's a pH. Let me just um, give you as a poll so it'll be easier to answer. Let's just see the question first. The pH is 7.34, the PCO2 is 25, and the bicarbonate is 15. All right, so what do you think? What is this thing? Remember everything I told you. But I know it can be harder if you are doing it for the first time, but uh, if look at the pH first, is it acidotic or alkalotic? Look at the PCO2. Is it uh, going for respiratory acidosis or alkalosis? Look at the bicarbonate. Is it respiratory or metabolic alkalosis or acidosis? And give the answer. So let's start the poll. Where's the poll? Here. All right, so here is your time. I'll end the poll after 1 minute. Right? I think you can see the question also. If you want to see the question, here is the question. Give your vote. Is it respiratory alkalosis, metabolic acidosis, respiratory acidosis, metabolic alkalosis, or mixed problem? Anything you want, just vote it. Right. I'm ending the poll now. Anyone want to vote? Just put your vote on. You cannot get that much time. All right, let's end the poll. Okay, so I can see that uh, uh, respiratory acidosis, 1% clicked it and 2% clicked mixed problem, but one of three, two. I think three of you are here. All right, okay, that's good. That's good. All right, so this thing is mixed problem. This is a mixed problem. Very good. Mixed problem of acid-base imbalance, and how you say it or how you interpret it. Look at the pH first. The pH is 7.34. So this is less than the pH, but it is almost normal, right? This 7.34 is almost normal, but it is less than the normal pH, 7.35. So you say, okay, there can be some acidosis. Look at the PCO2. The PCO2 is 25. PCO2 is 25. So you see, okay, that PCO2 is 25. It is less than normal. So it is when the PCO2 goes down, it's an alkalosis. But when you look at the bicarbonate, it is less, 15. So take it into account first. The bicarbonate is 15. So let's say it is a metabolic acidosis. So bicarbonate is 15. So what would be the compensation for PCO2? And we know, following the Winter's formula, the PCO2 should be 1.5 times the level of bicarbonate, that is 15, plus 8 plus minus 2. So it should be 1.5 times 15. What is this? I'm bad at math. Let me start my calculator. 1.5 times 15 equals 22.5 plus 8 plus minus 2, that is 30.5 plus minus 2. That means it should be 32.5 to 28.5. This should be the level of carbon dioxide. But you see that your carbon dioxide level is much lower than your compensation, than your preferred compensation. So what is this? There is a mixed problem. The bicarbonate level, the carbon dioxide level is not compensating. It's a mixed problem. So what is the mixed problem? This thing, in this particular case, this is a metabolic acidosis. At the same time, there is respiratory alkalosis. Both of them is happening here. So can you tell me one condition that can cause this thing? Okay, this thing can happen in salicylate poisoning. In salicylate poisoning, what happens that in early salicylate poisoning, there is there is stimulation of the respiratory drive. So what will happen? The PCO2 will go down. But in the late case of salicylate poisoning, the salicylate metabolites, they accumulate in your body and they cause salicylic acid accumulation. And this new acid causes acidosis and brings the bicarbonate down. So this is a kind of mixed problem, right? Okay, so let's stop for now. And do you have any question you can ask? I think you can ask it in the, what is happening? Let's see. Okay. There's a public chat option. You can ask a question here, or there's a question and answer poll here. You can ask question here. All right. If you don't have any question, I'll stop for now. Nice meeting to you guys. It was a great session for me. I mean, talking to you. And okay, there's the question. Can you explain the rule of compensation for respiratory alkalosis? All right, so Dr. Zareen, all right, Dr. Zareen asks that can you explain the rule of compensation for respiratory alkalosis? Okay, let's see what is the rule of compensation of respiratory alkalosis. I didn't, okay, all right. Let me share the thing. Okay, here. Respiratory let's go to the respiratory alkalosis part. I think this is the, okay. So the rule of compensation for respiratory alkalosis is that in case of respiratory alkalosis, what will happen? The pH, first the pH go high, right? And as it is a respiratory alkalosis, the PCO2 goes down. Because when the PCO2 goes down, pH goes high. So as a compensation, you'll think, okay, there will be decrease in serum bicarbonate. The bicarbonate will also go down to bring the pH towards normal. So how it happens? For every 10 millimeter, for every 10 millimeter of mercury decrease in PCO2, this bicarbonate level decreases by 2 milliequivalent per liter. So this is the compensation. For every 10 millimeter decrease in PCO2, the bicarbonate level goes down 2 milliequivalent per liter. Got me? It's good, right? Okay. Is there any other question or anything you want to say? Mhm. Okay, so let's stop the sharing. And here is another question. Can you give an example again? For what? For this respiratory alkalosis. Yes, okay, so respiratory alkalosis, the example is, where's the shared thing? Yeah. Okay, sorry, I am using this software also very first time. Sorry for that. Okay, so respiratory alkalosis, the example is when there is, uh, when you are breathing out more carbon dioxide from your body, when you are breathing out more carbon dioxide in your body. Like, as I gave you an example earlier, the question, the salicylate poisoning, early phase of salicylate poisoning. What is happening? When the salicylate is in your body, the salicylate is stimulating your respiratory drive and you are breathing out the carbon dioxide. So the carbon dioxide level is going down. But the body is trying to compensate it by by decreasing the bicarbonate level. It will try to decrease the bicarbonate level so that the pH goes towards the normal. But this thing, this salicylate poisoning, as I gave you the question earlier, this is kind of different because in the early case of salicylate poisoning, there is a stimulation of the respiratory drive, so the carbon dioxide goes out of the body. But in the late phase, what happened that this salicylate accumulates in your body. And when this salicylate accumulates in your body, it causes acidosis because it's a new acid and there is metabolic acidosis. So the example I gave you, the mixed problem where there is a respiratory alkalosis at the same time metabolic acidosis. All right, let's see. With numbers, that question I gave you earlier is an example of respiratory alkalosis at the same time metabolic acidosis. And if you ask me a new example, all right, let's make something new like respiratory alkalosis. There should be pH more than 7.45. Suppose it can be 7.5. This is an alkalosis. The PCO2 will go down. So let's say it is, what is the normal value of PCO2? This is 38. So let's say this is 28. This is 28 millimeter of mercury, right? And what is the bicarbonate normal value? This is 24 to 28. So what will happen for for respiratory compensation? This bicarbonate level will go down 2 milliequivalent per liter. So if it is a compensation, in normal compensation, it can be something like 22 milliequivalent per liter because the PCO2 is going down 10 millimeter of mercury, and at the same time, the bicarbonate is going down 2 milliequivalent per liter following the compensation. So this can be one example of respiratory alkalosis. I think you got it. Let's see. Here's some chat. Mm. I have to listen to your lecture one more time. I wish I had time to go through my notes. I have different formula, tic-tac-toe method. Okay, no problem, no problem. And here's the thing. Thank you, no problem. No, anything else? Anything? Any other question? No problem. Thank you very much. Thank you everyone for joining this session. And I had a great session myself. This new software thing is good. I'm recording it and I will send you the link. I think I'll upload it in my YouTube channel and with a shareable link so you can watch it if you want again anytime. All right. So let's stop this session for now. You said after PCO2 is 28. Uh, what exactly you were referring to? PCO2 is 28. Yes, PCO2 level is going down because Dr. Zareen asked me to give an example with numbers. So this thing, let me go back to the page again. And here you see that the PCO2 is going down, because this is the respiratory alkalosis, right? So when there is respiratory alkalosis due to any cause, the PCO2 goes down, and it is 28 millimeter of mercury. It is not necessarily the salicylate. Forget it. It can be any cause of respiratory alkalosis. There's several different causes of respiratory alkalosis, like hysteria. Hysteria is what? When it is the person is panic attack and breathing in and out, right? What happens? The PCO2 is going down. So the PCO2, if it goes down for 10 millimeter of mercury, the bicarbonate will also go down for 2 milliequivalent per liter for every 10 millimeter of decrease in PCO2. That's why I made this example up, that when the PCO2 goes down for 10, the bicarbonate goes down by 2, and the pH goes high, 7.5. Good. This is not necessarily a hard and fast rules. This is just a made up example. So you need to think about it. When you see the actual questions, you need to think, okay, that, all right, yeah, I think I got it. That, okay, this can be like this can be, this is an all over, this thing is all over the place. This metabolic and respiratory acidosis thing is all over the place. So you need to make your mind work. Okay, this can be like this can be like that. All right, so let's see. Uh, this computer, I think the uh, picture, the sharing is good, right? This software is really good, I think, because previously I used to use the Skype, but that is very limited capability, so I switched here. And by the way, once again, I'm starting my new session tomorrow, 16 weeks of session. If you want to join in, let me know. All right, so take care, everyone. Have a good day. Have a good studying. And I'll share the link to your email. Please check your email. Thank you very much. Goodbye.